Hi, my name is Jan Špaček. I'm the Science PI on the 2024 NIAC Phase 1 project entitled Add-on to Large-Scale Water Mining Operations on Mars to Screen for Introduce an Alien Life. Dr. Steven Benner is the PI on this project. Working with me, we have 2 interns and several volunteers on the project to search for extant life on Mars before we send humans there. For decades now, the astrobiological community has been convinced that indigenous extant life is a realistic possibility on Mars. Yet since the 1976 Viking missions, instruments sent to Mars would fail to detect active life in sparsely inhabited Mars-analog soils on Earth. The planned crewed exploration forces us to act now. In 2021, we decided to answer this call and design the Agnostic Life Finder ALF. ALF is to be used in conjunction with the Mars In Situ Resource Utilization, or ISRU. ALF development is supported by Agnostic Life Finding Association, ALFA Mars, by Foundation for Applied Molecular Evolution, and now also by NASA NIAC project. To understand our ALF mission, you should know that the mid-latitude subsurface ice was determined as one of the most promising sites to harbor extant Martian microbes. The mid-latitude subsurface ice was deposited during the high obliquity periods in layers of dust and ice. If the microscopic life was present anywhere on the Mars surface in the last 4 million years, it would be deposited in these ice dust layers. This deposited life would be either still living or at least conserved for million years. Therefore, if we analyze large enough sample, we would know if there has been extant life anywhere on the Mars surface since the ice was deposited. To obtain sufficiently large sample of the subsurface ice, we decided to link our instrument with the planned water mining on Mars. Sustained presence of humans on Mars will require ISRU water mining. The mid-latitude subsurface ice is the likely target of these activities. ISRU testing missions, such as Honeybee Robotics' Redwater Rodwell, will be on Mars likely long before humans leave the Earth to Mars. Our ALF is designed to expand the scope of the water mining missions, like Redwater, into live prospecting missions. Thus, we turn the ISRU activities bound to happen soon into very large-scale astrobiological experiment with very little additional costs. The target of our research are genetic polymers, based on a concept created by Steven Benner, polyelectrolyte theory of the gene.
From synthetic biology, we have learned that there are certain features of informational molecules like DNA or RNA that will be universal in the solar system, but also in the cosmos. That is, no matter whether your life is Klingon or Vulcan or human, you will have an informational molecule that will have a repeating charge in the backbone. DNA is an example of these. It has a repeating negative charge in the backbone held together by phosphates. That's universal to every form of life in the galaxy. In order to gain access to the informational needs of Darwinian evolution, we'll have a genetic polymer that has a repeating charge in it. Sometimes that might be a positive charge, sometimes it might be a negative charge. This allows you to concentrate from very dilute solution, very sparse life, very few informational molecules that might be important for this life form on Mars or elsewhere to support Darwinian evolution. Once you've concentrated the informational molecules needed by this Martian life, you'll be able to analyze them and determine what other characteristics they have that would also establish these as unambiguous biosignatures, unambiguous statements that, yes, there is life in this particular sample.
ALF will be sitting on the stream of the in situ resource utilization water on Mars. The water will be passed through a sonicator where potential compartments of the Martian life will be disrupted. Then the stream continues to ALF, which is a stack of membranes forming a membrane electrodialysis cell, which separates molecules and particles based on size and charge. So charged molecules are attracted to electrodes. Negatively charged particles like DNA would move towards the positively charged anode, and positively charged particles such as positively charged proteins we know from Earth
will move towards the cathode. So will also salts from the Martian soil or dissolved in the ice. But unlike the large polymers, which are retained by the ultrafiltration membrane, smaller salts can pass all the way towards the channel number 2 and channel number 6. In channel 3 and 5, we have concentrated DNA or concentrated polyelectrolytes or molecules which are small enough to pass through this microfiltration membrane, but big enough to be retained by the ultrafiltration membrane. The similar situation is on the other side, where we are concentrating polycations, such as alien DNA or some proteins which have positive charge. And then these isolated polyanions and polycations are concentrated and analyzed using mass spec or nanopores.
And so what has been done in the initial 5 months of the project? I've assembled a team of interns and volunteers, all eager to find life on Mars before we send humans there. I've taught them how to assemble and operate both membrane electrodialysis stacks, the small ALF, which is a batch-operated testing device, and the large ALF, which is the continuous polyelectrolyte extraction device. We've run many experiments mapping multidimensional landscape of applied voltages, flow rates, and salinities in all channels. We've designed and manufactured different geometries of the stack to improve its performance. We proved that we can move DNA from the sample channel to the concentration channels and that it is retained there. We tested several different membranes for each position in the stack. Based on the performance, we selected specific sodium exchange membrane, ultrafiltration membrane, and microfiltration membrane. Based on the literature, we've selected, designed, and ordered parts for a radially focused compact flow-through sonicator device that we are about to assemble. We are now testing efficiency of extraction of DNA from mineral surfaces in ALF. And what remains to be done in the next 4 months? We will continue to improve the instrument robustness and repeatability. We will design procedures for sterile operation. We expect that the late delivered in-light spectrometer we just connected will speed up the rate of the future experiments. We will link the sonicator, ALF, inline spectroscopic detector, and MinION readout. The spectrometer will provide continuous data, while MinION will be operated in batches. We will use ALF to extract genetic polymers from Arctic ice core samples donated by the University of Florida. We will summarize our findings in a publication to be submitted in December. On top of the work we've done in the lab, we started a collaboration with Honeybee Robotics on a mission design that integrates our life-finding instruments in their water ice mining rover. We are now searching for investors for the joint mission to prospect for extant life at the future crewed landing sites on Mars.
Hey, this is Chris Temby, the president of the Agnostic Life Finding Association, ALFA. We want to thank you for watching through the video and wanted to point out the fact that in an era of democratizing the private space industry and opening more access to space for the global public, there's definitely a conversation that we want to encourage about the search for life on Mars and throughout the solar system and in the universe. And we've started a global campaign for social media and marketing, and we're going to provide some of that at the end of this video here, so hopefully you enjoy. Thanks again.
Is there life on Mars? New evidence suggests that life may not have only originated on Mars, but has found a way to survive there. However, definitive proof awaits discovery on the planet itself. But in our mission, time is critical. As nations and private industry race to Mars, a pivotal discovery could be slipping through our fingers. The chance to discover Martian life before human activity contaminates the landscape forever. Are we alone in the universe? Let's find out.